Any of these were like solving, you had to solve for something. Number 1, you needed to solve the equation. You needed to distribute twice, and then get all the variables on one side, all the constants on the other. After you move all of those around, I did this math in my head, so if you did not get the same thing, let me know. But what I got was x equals -7. Did we all get the same thing? Yes. Okay, good. Remember that once you get to like this part, there are different ways to solve it. So if you didn't solve it exactly as I did, don't erase. It's okay. Number 2 was a type of evaluating function notation question. You had to put -4 in for all of your x's and figure out what your y would be. So this really should continue to say f of x equals, but it doesn't. Another way to write that is f of -4 equals -8. Both of those are the same thing. Number 3, you needed to translate this. 6 less than a number, that really means 6 goes at the back. After that. So whatever variable you want, subtract 6. Questions on any of those 3? You need me to come back to this. On the back, number 4 asks you to solve the following. If you start to solve this, if you remember that when you have the same coefficient but different constants, that would give you no solution. You could have also solved it, and you would have either gotten -8 equals -2 or 0 equals 6. Either way, those numbers don't equal each other, so your answer would have been no solution. For number 5, you needed to solve this equation for y. So you could either subtract 2 from both sides and then solve for y like that, or you could have, and this is not up there, but added 3y to both sides. You would have had to then subtract 9 and then went through it like that. And then there were a couple different options you could have for your final answer. If you divided each number separately and went through it this way, y equals 2/3 x minus 3 would be your answer. If you divided the entire thing, you could have left it like this, -2x plus 9 all over -3. Or if you distributed the negative throughout it, 2x minus 9 all over 3. If you separate that fraction out, it becomes what we had originally. Questions on either of those? Did anyone have questions on the Delta Math or Khan Academy stuff? Khan Academy was due last Friday. Delta Math was due Tuesday. Did in class, but I think the Khan Academy graphing it was a little weird because we had like moved the points. If you have not done those, make sure you do those. Remember that all of those grades go in this marking period, which you should now be able to see. Speaking of, if you have not finished your test, you have zeros in for that, so come get that done as soon as possible. That could be after school today, Friday morning, or sometime next week, but as soon as possible. And then if you finish your test already and you know that you want to retest one of them, it's going to work the same way. Benchmark towards the end of the quarter, which will be in January. But you can start that process early. Come after school, come before school, work through that. It'll be the same thing. You'll need to do test corrections, your contact, math, additional practice if you scored below a C, and make sure all that stuff is done before we take the benchmark in January. The longer you wait to do that stuff, the more you'll have to scramble to do that stuff at the end. So getting that done ahead of time will benefit you. So the last couple of classes we were talking about solving systems of equations by graphing. Today we're going to be solving systems of equations by substitution. So you should have those notes on your desk. And I'm going to fill this part down so you guys can fill that part out. So, substitution method is a method of solving systems of equations by substituting equations within one another. Kind of like evaluating, you're substituting a value for a variable when you evaluate, but here we're taking an entire equation and putting it into another. So the steps for this are we solve one equation for x or y. Some of them will already be solved for an x or a y. It just depends on the equations we're given. Then we'll substitute that expression that we solved or was already solved into the other expressions. So not the same one we solved, but the other one. And then we solve for whatever variable is left. After we get that variable, it'll be like x equals some number or y equals some number. Then we're going to take that number that we solved for, put it back into one of the equations, doesn't matter which at that point, and get the other variable. So really, it's a lot of solve, substitute, answer. And number one has two equations that are both solved for y. So we don't have to solve for y because it's already there. But because these are both a y equals, we're kind of going to substitute them into each other. Because this is y equals and this is also y equals, I can say that these are equal to each other. They both equal the same variable. So I can say that this is the same thing as setting them equal to one another. It does not matter which part you put on which side, as long as they're equal to one another. In this case, we substituted, I could say I put this one into this y, or I put this one into this y. It doesn't really matter. They both kind of went into each other. But now that I've done that, I'm going to solve for x. Again, it does not matter how you choose to solve this. I get all the variables on one side, all the constants on the other. So I'm going to start this by subtracting 2x and then adding 1. So this would give me 2x and negative 4. I could divide both sides by 2, and x would be negative 2. Once I have one of the variables, I can put that back into one of the equations. It does not matter which. I'm going to put it back into both to show you that both would work, but you don't need to do that. You can just pick one. Okay, y equals 4 times negative 2 minus 1, or y equals 2 times negative 2 minus 1. So don't do both, pick one, and figure out what y is. No matter which one you solve, you should get the same answer, negative 9. After you have your x and you have your y, this is one solution, negative 2, negative 2. And that would be your final answer. Have any questions on how we did that, how we got the answer, that process? Move on to number 2. This one has an equation that's in y equals and then an equation in standard form. You don't have to change the one that's in standard form. We're just going to worry about the one that has a y equals already. Because this has a y equals, I want to substitute this into the other one, where y is. So I'm going to take this equation, the second one, I'm going to rewrite it. But instead of writing y, I'm going to write this equation, 6x in parentheses. And solve for x. So this will give me 20x equals negative 20, divide both sides by 20, and x is negative 1. So we took the equation we were given, we put it or substituted it into the other, solved for the variable, got the answer to that variable. Now we need to put that variable or that answer into one of the equations. You can put this into either, but the easier of the two would be the one where it's already y by itself. Substitute the answer you got for x back into one of the equations you were originally given. Does not matter which one. Find your answer, and then once you have your x and your y, you can put them together and solve it. questions do we have so far? Same process. This one has y equals. So, and again, we don't need to solve the one that's not in y equals. We're going to take this equation, this x plus 9, put it in for the other equation where y is. I'm going to rewrite this bottom one, 3x plus 8. And instead of putting y in parentheses, I'm going to put an equation that y equals x plus 9. And solve for x. So this would become 3x plus 8x plus 7. And then 11x plus 72 equals -5. You can solve for x at this point. Subtract 72 on both sides. And divide both sides by 11. So x equals -7. And then once you find x, you can put that back into one of your equations you were given to find y. Again, it does not matter which one, but the one that solves for y will be easier. This would give us y equals 2. Once we have our x and our y, we can put those together in an order pair, -7. Once you get the hang of the process, it's like the same each time. In number 4, we have an x equals, not a y equals, but that's okay. We can still use that, even though it's not a y equals. The process is going to be very similar. So if I have an x equals, I'm going to take this equation, put it into the other one where x is instead of y. That's real different. So when I rewrite this bottom one, it's going to be 2 times 4y plus 7. And then I write the rest of this equation, -6y equals 12. So because I started with an x equals, I put that in. I'm now going to be solving for y, and then have to go back and find x. So this would become 8y plus 14 minus 6y equals 12. Combine your like terms. It would just be 8 minus 6, so 2y. And then we can solve for y from there. Subtract 14 and divide both sides by 2. We have our y value. We now need to go back and find our x value. So again, put this back into one of your equations, doesn't matter which, but the one that solves for x would be easier. So this will be -4.7 or +3. You still need to put this as an ordered pair, but remember that you solve for y first. So it still has to be the second number in your ordered pairs. Not the other way around. So leave this before I flip the page. I think we'll have time for one more. Do you have a question? So with number 5, you have two equations in standard form. Neither of them are solved for an x or y. So we need to solve one for an x or a y. Most of the equations that are good substitution problems have one of these variables by itself. Whichever variable in whichever equation is kind of by itself has either positive 1 or negative 1 as a coefficient, that would be the one to solve for. Not that you couldn't solve for anything else, you definitely could, you'll just end up with fractions and have to be careful with that. So for this one, if I solve this one for y, I would get rid of my x term by subtracting. I switch x and the constant just out of habit of writing it in slope-intercept form, but if you left it as negative 2 minus 2x, that's fine too. And now that we have an equation that is a y equals, the process is the same. We're going to put this equation into the other one where y is. So that would look something like 5x plus 3 times negative 2x minus 2 equals negative 2. So in problems like this, there's like an additional step. But after you do that additional step, everything else is the same. This becomes negative 6x minus 6. We can combine the terms and solve for x. Here we had a y equation, so when we put that in, we ended up with x. Once we find our x value, we can put that back in. So we have a few different options. You can put this x into the original two, one of the original two, or the one you solve. I personally would be the one you solve because your y is by yourself. You don't have to solve it again. But any of the three would work. And then once you have your x and your y, you can put them together as an ordered series. Kind of connecting this back to the when we were solving by graphing. All of these have one solution, which means all of these lines intersect somehow. None of them are parallel lines. None of them are have the same slope and y-intercept. So tomorrow we're going to do one or two more examples, and then you'll have time to practice. For the remainder of class, you also have time to practice. I'll mention this again tomorrow, but you do have one Khan Academy on this, what we did today, due Friday. I'm sorry, not tomorrow, Friday is what I meant. And then one Delta Math due next Monday. So if you are having difficulty with this or the stuff we did last week, come see me after school today. We can go through problems together. Remember that I am not staying after school on Friday, but you can also come see me in the morning before class.